Hey guys, somebody give me a 5 for 5. Let me know what's up. Yeah, I hate it when it does. My Wi-Fi went out, guys. Yeah. My phone quit working, my TV, my Netflix was on in the background there, all muted and everything. It all went out. Yeah, that's what happened. So just so you know. Yeah, we're back. Yep. Guys, do me a huge favor. Please share this. If you guys don't share it, it ain't gonna make it out. Usually YouTube will not send out another notification that close to another one. It just doesn't happen. And I was trying to get done before Marfugal went live, and they're over on Marfugal News right now, I think. So please go watch them. You can watch me on replay. I try to get done before they start. I'm a mod over there. You guys know that. And they do great work. Heck, half you guys here came from there, if not more. So I would have appreciated, though, if you guys would watch them and then, come back here and watch me on replay. I get it. And that's really, and what I'm talking about tonight, we don't have like G4 storms or nothing. So it's not like it's like urgent stuff. So, yeah. So I do appreciate you guys coming back and watching, though. I just hate it when stuff like that happens, because literally, guys, I was just about ready to get into the meat of it, and we probably would have been done in like 10 minutes. But anyway, so just to kind of go back over where we're at, guys, you can see this right here. They were forecasting a geomagnetic storm, G2. We did not get there. I don't think we're going to get there. They've downgraded their geomagnetic storm watch to a G1, and it should have happened like right now. And we are getting space weather right now. It's just not as strong as what they initially had expected. And the reason why, in my opinion, I was just explaining that. This coronal hole here is what's giving us the weather. It was over here a couple days ago, and we connected to it magnetically. And I was just explaining that when the Wi-Fi went out. So let me get you back there again. This is NASA, the Enlil spiral. Remember what I said a few minutes ago, if anybody that was here. The interplanetary magnetic field lines, that's this dashed line right here. Everything's connected to it. Like I said before we went down again, if you were naked out in space, your naked butt would be connected to the sun magnetically. All of these satellites, everything out there. This is our inner solar system from the top down. That's what you're looking at. Sun's in the middle. Earth is this yellow ball over here. Okay? These are some of the satellites that are hanging out. That's Mercury. You always notice Mercury moves fast. It orbits the sun fast. This is Mars out here, and this is Venus. Okay? It doesn't show anything out past that. Well, it does, but the next planet isn't there. Jupiter. So, anyway, this dashed line is an interplanetary magnetic field line. That space weather from the coronal hole gets here on that line magnetically. So, with that being said, remember, magnetics, you have to understand you have a negative and a positive, right? So, if you're in a negative position, anything positive coming at you is going to get sucked right over to you, right? Opposite polarity. So, if it's reverse of that, it actually repels. So what you're looking at is when you're in a different polarity position, that's why the BZ matters. Okay, this red line here I talk about all the time. So what you're seeing here, guys, -6 is what we look for. Okay, this is our magnetic position. So when the BZ is, that's what we're talking about here. Now, the phi angle is actually the actual polarity of the solar wind, okay? So, when these two things are opposite one another, things just kind of move, right? So, the phi angle is what we call the solar wind's polarity, right? So, when that angle flips, because it does often, you see this right here? That's what it did right there. When you see the blue to the red like that, that means the phi angle, the solar wind's polarity, flipped. It does it multiple times. It can do it very, very quickly. And sometimes when it does it, especially when it does it in a rather dramatic way, it'll put us into a geomagnetic storm. Because it yanks on our, everything is getting yanked magnetically like that. And it causes our magnetic field to be in an unstable position. And it lets things in. Things just kind of flow in when that happens. It doesn't usually last very long, geomagnetic storms that are caused by the phi angle. Just phi angle alone is what I'm talking about. But if you guys look at this, everything moved right here. You see this? So the BZ started to move away from the BT. I'm not going to get into what that actually is. So anyway, when these two start to separate, yeah, that's when you start seeing space weather. And the phi angle flipped at the same time. The density started going up and down, right? The density actually kind of dropped out. But it was back and forth, back and forth. Then it went here and it stayed kind of south. And the reason why is because the solar wind reacted too. So when the solar wind, this purple line here, gets fast, the density usually drops. Because if you think about it, it's carrying more particles away because it's moving faster. So that's what happens. And then obviously the temperature is going to change, drop, and raise depending upon what's going on overall, right? That's what we're looking at there. That's the green line. So -6, remember that. And then, you got the phi angle. That's the polarity of the solar wind itself. Now the density can be from CMEs. It can be from the solar wind. So is the speed, okay? That's just the speed of the space weather stuff, particles coming at us. All right? And that's just the density, the orange line. Those are what those data points mean. Now, I know I just threw a bunch of info at you, and I don't expect everybody to remember that. But I do want people to understand. So, if you guys stop, pause, and rewind and listen to me a couple times, please do. I do have a solar wind explanation in a playlist if you guys were interested in watching that. It's very short. It's like 2 to 3 minutes long. It's not anything special. It really truly is just to say, hey, this is what solar wind is. Hey, this is what a CME is. So yeah. And I would also say this too, guys. If you guys want some really good explanations on those kinds of things, and I've said this the past 3 videos, but it's because it's the truth. Go over and check out Tamitha Scove's channel. She really does a great job. Tamitha Scove. Tamitha, S-K-O-V. If one of my mods, if you're kind enough, please, you guys could drop her link in there if you would. I've never even talked to Tamitha. I just think she does a really good job. She explains things at a level that everybody can understand. She doesn't usually try to throw a bunch of word salad at you. And when she does explain a word that we don't really know, she's able to do so to where we can understand it. And I'm putting myself in that because I'm not secondary education, nothing going on here. She's way above my pay grade, I promise you that. So are a lot of people. Well, Ben Davis, the same thing. He's way above my pay grade. And these guys understand space weather so much more than what I possibly ever could, probably. I'm confident enough I could be taught, but they've been to school for it. They know all the stuff. So, obviously I'm going to point you that direction. So anyway, so we're connected, right? Magnetically. So when the solar wind gets here, that's what we're looking for. We're looking for that polarity usually. And then the speed and the density. The density and the speed can actually overcome that, the magnetic polarity not being in the correct position. So if we're getting a CME or solar wind that's moving really, really fast and really, really dense, it will come on through. Now, it won't be as strong as what it could have been, but that's what happens. That's why we have our magnetic field. So let me take you guys over to, I'll tell you what I'm going to do first. I do want to show you guys this coronal hole from a couple days ago, just so you guys have a better understanding of what. And I showed this in my last stream too. I'm just going to stop it a couple days here. Let's just do one day because I just want to show you pretty much a still shot. Okay. So there's that coronal hole. See how much bigger it was? Now remember, the parallax effect is in motion there too. As this thing went, is moving, rotating away. Just because it starts to look like it's smaller doesn't necessarily mean that it is. Things on the sphere look smaller on the sides when you're looking at them straight on. So anyway, this was a very sizable coronal hole, which is why they were, one of the reasons why they were forecasting a G2. Okay, a G2 level storm. Now, a G2 level storm isn't, write home about type of stuff, but it is significant. Okay. We can see some things with that, increased aurora. We could see some small electrical issues. Now remember, because our magnetic field is like weakening. Remember, I think was it last year, earlier this year, we had a G1 storm during a SpaceX launch that affected the launch of the satellites, and they lost some satellites because of it. Now, they had launched in those conditions multiple times before. So why was this time different? You got to ask yourself that, right? And then, like 2 weeks later, we had another G1, very little, small storm, another launch from a different company, and they lost satellites. So, you really got to wonder, is our magnetic field now getting into a weak enough state that they're really going to have to adjust what they're doing? I hold the opinion that, yeah, they're going to need to. And that's just my opinion. And, I'm not going to sit here and try to force that on anybody. It's just an opinion I have, and a lot of people share that, but some people don't. And I respect that. But anyway, this coronal hole, remember, this is just the surface of the sun, the black, right? The surface of the sun is colder than the atmosphere, the corona. So that's why the darker colors on here on SDO they show up, they're colder. Okay, that's why. And you're looking at a gas that our eyes cannot see. It's the 211 angstrom of the light spectrum. So they do this, they put the filter on here, and the 211 angstrom does not mean that it's purple, right? It just means that's the color they assigned it. They could have made this any color they want. And actually, you can go to other sites, and other websites will have the 211 in a different color. So you got to pay attention to the angstrom, okay? That's really what you want to look at. Our visible spectrum is a very, very small part of the overall light spectrum. I'm talking minute, okay? So that's why they have to do this. And when we look at these things, we don't just want to look at one angstrom. We want to look at multiple different ones, because different gases show up differently in other parts of the spectrum. So we get a more comprehensive look. So just to give you an example, if you want, you check that. Remember this image here. I'll back this off, and I could change. I could change the angstrom right here. What I'm going to do is I'm actually going to take you guys to a composite. Okay? What these composites are, they're 3 different angstroms at the same time, laid down on top of each other. I'm going to pick one that has a 211, which is this first one. So it has a 211, 193, and the 171. So I picked that one. Watch what it does. Okay? Come on. They're not going to give it to me? Huh. Maybe it's not going to let me have that one. Let's try this one. Nope, it's not letting me see the composites. I wonder why. It's going to go back to that one. Nope. SDO's not responding, and I don't know why. So let's, I'll tell you what. Let's go to, I don't know what that means. Hold on 1 second, guys. Sorry. Hold on. I tell you what, I am having all kinds of technical issues. My stupid charger come unplugged. You believe that crap? It might have been I guess, part of what was going on. I doubt it. My Wi-Fi had nothing to do with this charger, though. So, anyway. So, let's see if I can go back to SDO. I apologize, guys. This stream is kind of all over the place. I'm sorry. Let's try this again. Let's go to another composite. I hate it when these streams go like this. It's frustrating for me, I tell you that. And I know I appreciate you guys sticking around even when I'm having issues. I apologize. I try to have it all ready for you guys, but and SDO's not even responding. That's stupid. I know the internet's on because I could see it. And I'm jumping back and forth around. That 211's there. Wonder why it's not letting me see the composites. That's kind of crazy. Anyway, we can look at composites, guys. I'm not going to right now, obviously. But anyway, it'd be 3 different gases to get laid down on top of each other. And it gives you a total different look. This hole would be covered up a little bit. You would still see a kind of dark shadow. But the other ones would be laid there too. So you would be able to see other details. So it's a good way to see if plasma leaves is actually able to escape the sun. Which, you know, if it doesn't, it comes back down as what we call solar rain. It's just plasma going back to the sun on one of those magnetic connection lines I was talking about. Okay? So, yeah. So that's that part of it. Now, there was a small little CME right here. It looks like it's moving kind of fast. But it doesn't even look to be hitting us anyway, so I'm not even going to concern myself with showing that to you guys. It'd just be a waste of time. So, now, so like I said, we've got some solar weather hitting right now, and I'm going to show it to you. This is our magnetosphere, okay? The sun's off to the left. Space weather is moving from left to right here. Okay, I'm going to show you magnetic pressure, density, and velocity. All right. So as we look at these, you'll be able to see these waves just come in. It's easy to see, is what I'm saying. See these? Okay. So the darker reds here would be faster winds. Okay. And as this thing just progresses, you can see it. It's nothing too drastic right there, I would say. But you can see that we had an increase here. When you start seeing these fluctuations. And remember, this right here is matching what we're seeing here. Okay, up and down. So what's happening, just so you guys understand, you're seeing these data points, right? These data points are being entered into this model. And it's giving us a visual. Now, did you guys see that? I know you did. So that actually happened a little bit earlier today also. What that is sometimes our magnetic field will actually anticipate these things. It'll start to sense things are getting closer. And it will actually, our bow shock, this initial point of contact, will shoot out to help give us a little bit more protection. Okay? And then when the solar wind hits it, it compresses back in. And it bounces back and forth, and you get reverberation and everything else, sometimes for days. And that's what causes geomagnetic activity to hang around. A lot of the reason why, anyway. But what you're looking at here is density. The blue is the darker density. And when you see these, like, remember, you can't really see the bow shock here, can you? Like you can up here. Hold on. Let me move this. See how defined it is right there? But if I go down here, it's not really there, is it? Now, I want to point something out because somebody's going to tell you that our magnetic field went down. And that did not happen. All right? All this means is that the density on one side of this bow shock and the other is the same. That's all that means. They don't understand this model when they say that to you. And I used to actually believe the same thing until I, understood what was going on. Now, I know that looked pretty impressive, and it was, right? But that was not a density hit. You know what that was? That was a increase in speed because it turned white, didn't it? The whites are the lower density. So that means we were getting hit with faster wind. That's why it's important to understand what you're looking at here. And if you don't, it's all good and dandy. Now, it is, seriously. But what I'm saying is, there's people out there that want to go talk about all this and they don't understand it. And that's okay too. I get that. I was the same way. But when somebody corrects them, they need to come out and correct themselves. I've corrected a few people, but I never do it publicly. I do it behind the scenes because it's never productive to be like, oh, that guy over there, he's right? He's wrong, I'm right. That's not my point here, guys. That's not why I'm here. I'm here just to share and learn just like everybody else. So I hope you guys understand that. You're not going to see any of that drama BS here. It's just not going to happen. So anyway, as you guys can see, that's magnetic pressure. Okay? So what you're getting there is, the thing's hitting. Now, some of that magnetic pressure has been here all day. And some of it is residual from the geomagnetic storms we got. Now, you see how that pressure kind of went away there for a minute? That's because the speed of the solar wind hit, and it flushed out a lot of the particles. Okay, so the pressure went down. So I hope you guys understand that. And again, guys, we could get into G2, I guess. I don't want to say that we are. I don't think that we will. Now, if we do, okay, it's not a big deal. There's really not a huge difference between a G1 and a G2. Now, if we were talking the difference between a G4 and a G5, that's a little different of a story, okay? Because as you go up in storm level, the higher up you get, the difference one storm level makes is greater than what it is when it's down lower. Okay, the difference between a 1 and a 2 is way lower than the difference between a 4 and a 5. That's what I'm trying to say. Okay, so, and they do use the similar system like a severe thunderstorm warning, guys. It's very similar to a regular weather system warning, okay? But I wanted to show you guys that because that's something that really does show people, hey, this is what's happening, all the above, right? It gives you a really good visual, is what I'm trying to say. Now, let's look at the Aurora model. I wonder what it's showing. Yeah, it's increasing, okay? Anybody that's down here in the States, you guys might want to go out, anybody that lives up in here, you guys might catch some Aurora tonight. If I push play here. Now remember, they were seeing like southern lights from New Zealand and everything else during the storm the last time. We seen Aurora in Arizona here. All around the planet on that latitude line, we've seen Aurora. So it means that the overall storm itself was powerful enough that it pushed the Aurora down that far. What I mean by that is, sometimes we'll see Aurora down here, like really far south, Arizona, sometimes even Florida, Texas, Oklahoma, those kinds of things. A lot of times, those are just small cracks that open up. But when you see it globally come down to a specific latitude line, that means the whole thing, the whole event has pushed Aurora down that far. Okay, there are times during bigger geomagnetic storms, believe this or not, remember, I'm going to pause this and explain this because I think it's important to know. If you live up here in Alaska, and I'm not sure if I have very many Alaska viewers, if I do, somebody tell me down there, I want to know. That'd be pretty cool. Anyway, if you live up here, up here in the Arctic Circle, especially, there's times, and I'm sure you already know this, those that live up here, like right now, if you lived right here where my cursor's at, you would have to go outside, and guess what? You're going to have to look south to see this Aurora. You guys hear what I'm saying there? So what I'm saying is, when this Aurora oval gets pushed far south, sometimes if you're over here in Alaska, like here, if this gets pushed down, then you're going to have to go outside and look south. And you might see aurora all the way around you, depending on where you're standing and depending on the day and the event. So that's what I'm trying to say. So when you get the bigger, stronger storms, the people up here closer to the poles have to actually look the opposite direction of what you would actually think you would need to. Right? So anyway, I just wanted to point that out. I thought that was really interesting because like during like a G5 or like a Carrington event type of thing, yeah, even people up here in the northern states would probably have to go outside and look south. If you're getting aurora on the equator, yeah, if you live up here in Montana, you're going to go outside and you're going to have to look south to see the aurora. You might not be worried about that at that time because if we get hit like that, you're probably not going to have no power. So, those are like big events, like Carrington style type of things. And speaking of that, I'm going to give a shout out here, guys, too. I got an email from, I can't remember the website. I still need to go. I haven't had a chance to do anything, guys. Like I said, I fell asleep and I was out forever. Gosh dang it. It's an app. Carrington, was it Carrington? I don't think it was Carrington 2024. I'll give him a shout out in the next one. He gave me free access to the website app, and it's a space weather app, and I haven't had a chance to go surf it yet. But it's very generous. He just gave me free access. So it's awesome. I'm gonna go check. I think I've been there once before, way back in the day. I think it's the same app that Suspicious Observer Ben Davison used to run. I think he transferred it over to him. So I think that's the same map. So I'm pretty sure it is, if I remember right. But he seems to be a really nice guy and everything, so I will support that 100%. Any kind of space weather hub that I can point people towards, I'm going to, especially, if it's a good one. I know it's a good one because I've been there before. It's just been a minute. So anyway, in my next live stream, I will show you guys that one for sure, okay, and send you guys over there to go check it out. If you're here, listening to me, go ahead and drop it in there if you want. Let me know, and I'll, you ain't gonna hurt my feelings if you put it in the chat. No biggie, okay? So anyway, let's go ahead. Now, again, we should have been at a G1 during this right here. We got close. I wouldn't say close. They might be behind a little bit here. They might have missed it by a few hours. So I'd be interested to see, because we are getting hit with space weather right now. I'll tell you what we can do, though. Let me take you guys over here and show you this. And I know this is kind of laid back now. I just kind of feel, since it went down earlier, I hate it when it does that. Okay, so what you're looking at here, guys, is the GFZ. This is Helmholtz Center. This is Germany. It's a German website, okay? A space agency. This is a 30-minute increment data collection. These are 3-hour averages, okay? So if you want more real time, it's kind of here, right? And the reason why I wanted to look at this is because of this very reason. You see what you're looking at on this one. See how this is an average right here of 3 hours? Over here, you get to see those 3 hours, what happened during those and how they got their average. And what's important, what I'm getting ready to say here, you've seen it kind of go up. Guess what? It's already tailing off. But this next data collection might be different because we just looked at the magnetosphere and it was bouncing around. Right? So, yeah. Hey, Trinity. Hey, Kathy. Good to see you guys. Good to see y'all. Stephanie, good to see you. Hey, Debbie. Wrath, what's up? Just saying, hey. And again, guys, please share this out. When that first stream went down, it kills a live stream view. Anybody that's a YouTuber, Trinity, you probably know this too. Whenever that happens, it really does, because YouTube ain't going to send notifications out that close together. They just don't. But so please share it, guys, if you can. If you don't, all good. I ain't gonna be mad at you. So anyway, guys, that's the geomagnetic storm that, you know, we're starting. If we're going to be into storm level, we're going to get there fairly quickly, okay? It's not going to be much longer, and we'll be there. But this is spaceweather.com, okay? So you're looking at daytime aurora, right? This is Marjan Spikers on December 1st. Look, this is at noon. And saw the northern lights. I just think that's so stinking cool. I know it's not like in your face, you know, oh my gosh, look at that aurora. But remember, the sun's up. It's noon. Okay? So, yeah. Yeah. The island of polar bears is what it said. It's not easy to see aurora in the middle of the day when the sky is suffused with sunlight, is what it says. Yet that is exactly what happened to Marjan Spikers? Spikers? I don't know how to say that. There's a J in there. I'm thinking it's probably silent, but maybe the K is silent. I have no idea. I don't want to butcher the name, so I'm not going to keep saying it. Where was this at? Nighttime Sky and Svalbard. Okay. Svalbard, where's that? The island of polar bears, because of its large population of Ursus maritimus. I'm sure that's a breed of polar bear, I'm sure. Although it's technically night, the noontime sky, okay, still contains some blue from the. Okay, what they're talking about there, guys, right now, because it's wintertime, as it gets closest to the winter solstice, what you're going to see is you get 24 hours of darkness for a considerable amount of time when you're up that far north, okay? And it's because of the tilt of our axis. And I'll go into that more. And that's that whole reason right there is why I talk about, you know, when we talk about the moon and everything going across the sky and the position of it and what it looks like as it goes across the sky. There's a big hurdle for those guys to have to come across to explain and try to blame that it's not field rotation. They would have to explain why we still see the 24-hour night and day during certain times of the year. And those certain times of the year have not changed. Okay, and the explanation they give for what they see, they think because it looks like it's rotating as it goes across the sky, because it does from our point of view. It's called field rotation, right? But the explanation they give to why it's doing that is they say that our axis has tilted further than what it should be. If that was the case, the 24-hour daylight and the 24-hour nighttime, those locations would change. And drastically. Okay? So that would have to be explained. We've got sundials all over our planet that have been here for thousands of years and never moved. And they still work the same exact way. That would have to be explained. There's so many things that would have to be explained to blame it on a severe extra tilt in our axis. Okay? If you guys, if we tilted to 90 degrees, that means that almost 6 months out of the year, there would be places on our planet that would be facing the sun at all times. The sun would never go down. And it would just blast. It would, yeah. In other words, you'd have massive heat on one side, and then on the opposite side of the planet, guys, guess what? Guess what you would have? You would have extreme cold. So that's kind of what I'm saying. All those things would need to be explained if you're going to try to say that that's because of our axis tilt. So just saying. And I'll get more into that at a later time. I've explained that a few times. I get questions on that a lot, so I do address it once in a while. And there's more and more things that would have to be explained that I just continue to sprinkle in And I'm not just going to jump it all out there because there's so many of them. So, not to mention I got the math on it too. So, anyway, you got these big sunspots here in the middle. These are facing us right now. They don't look to be too complex or like getting ready to blow. They could. I'm not going to say they're not. So, but that's what could be happening. But anyway, guys, I am going to pop off. Please go watch Marfoogle. I'm sorry this stream was kind of off foobar and all over the place. I do apologize for that, but I can't stop the Wi-Fi from going out. My internet went down for like 5 minutes. So, anyway, guys, I did delete that first stream because if you don't, it just becomes confusing for everybody. So head on over to Marfoogle News, guys. Marfoogle TV, please. Check out Trinity. Check out Hilly Billy. Guys, check them all out. Hey, Hilly, you can drop Brian's channel in there too if you want. Guys, go check them out. Go check out Mark Pyers. Again, me and Mark and Trinity are working on getting on a live stream together. Our schedules are so crazy, at least mine is. We're trying to like line it up and everything. But it's getting, it becomes very hard sometimes to get everybody together. I think once we figure a time out that we can all be there, it might be able to be a reoccurring thing. So, we're working on that. But check out all those people and everything else. IG, check out Ron Tyler, Emergency Management Associates, guys. Hey, you don't have to thank me, girl. Yep, there you go. Guys, go check out Brian's channel. He's a great guy, guys. And especially if you guys are Christians, especially if you're not. Go check him out. Okay? Anyway, guys, God bless. Yahusha saves. And as always, you can drink this Kool-Aid.